Alright, guys, let's go for the foundation engineering class and chapter number 4. And this time we are going for the seismic bearing capacity and settlement in granular soil. Okay, so when earthquake happen, what will be the bearing capacity of your foundation during earthquake, and also the settlement, but it only for granular soil. Okay, so we have seismic event in some countries, not all the countries in the world. Some countries don't know what is earthquake, but in some country we have a lot of earthquake. So you need to design your foundation to stand against earthquake. Okay, so this reference proposed seismic bearing capacity theory, and this figure is showing the failure because, as I said, since last time, every bearing capacity is based on the failure mechanics. The assumed failure mechanism, whether it is true or not true, not actual failure mechanics or just approaching. So this one is showing the mechanism in case of uh, like a static condition. Okay, and this one is showing failure mechanism in case of earthquake, like a dynamic condition. So you can see these angles here, alpha A, and here alpha A, E, alpha A, E like earthquake. So this angle, inclination angle for active pressure condition, they are for active pressure condition. And these ones, alpha P, you can see alpha P here, alpha PE, okay? Those are for passive pressure condition. So the value of these angles are not the same. So according to the theory they gave the ultimate bearing capacity condition in granular soil, please remember that, can be given for static this condition. It means no earthquake, normal condition, static condition, given this form. And this is similar to the tensor gauge made of all the previous equation in static condition we have seen before. Okay, and dynamic condition, earthquake condition, we have this. Okay, this equation. So you can see the bearing capacity factor are here. Bearing capacity factor NQ and gamma. You know them already, I believe. NQE like earthquake, and gamma E. So the bearing capacity factor. So you can see that the only difference between these two equations are the bearing capacity factors in here and here. So static and dynamic earthquake condition. Okay. DF, you know already. The Q here is just the surcharge and shape. Okay, I will put this equation here. Static condition, earthquake condition. Okay, corresponding each this figure. So how do we obtain the N, Q, and N gamma in case of static condition? These are a function of phi. You know already them. And we in the chapter 3, the previous chapter, we have been many tables that gives this. Okay, so about same, no big deal, no big difference. However, in case of NQE, N gamma E, it means in the case of earthquake condition, this condition, these bearing capacity factor are different. They are function of phi, but also tangent theta. What is tangent theta and what is theta? Okay, phi you know already, frictional angle, soil frictional angle. But tangent theta is this, KH and KV. These are very important parameter in case of earthquake. So what is KH? What is KV? Okay. KH is the horizontal coefficient of acceleration due to the earthquake. Okay. Horizontal coefficient of horizontal acceleration due to the earthquake. If you don't understand what this means, don't worry, I will explain it very soon. Okay. KV is this. Okay. So these two parameters, horizontal and vertical coefficient of acceleration due to the earthquake, are obtained. They are measured during earthquake. When the earthquake happens, we have some devices in the ground that can measure this. Okay, so it is not something that like you calculate like that. Okay, so anyway, you can see now how we can. This is just showing that, telling you that this is function of this. Okay, and these two bearing capacity factor are function of this and this. Okay, so let's go now and explain. I want to explain more for those who don't know what is KH, KV. Okay, so this is like device seismometer that can measure. This is just one example. Okay, there are many types and many and this one, as you can see, it is like measuring like horizontal. So there are several types, and this is what is measuring the KH and KV. Okay, and the measurement will be something like this. Like this one is horizontal one, and you can see acceleration is here, and time. You measure time, acceleration. So when earthquake happen, this will move like this. So it's showing something like this. And this one is the vertical one. Okay. What is the difference between the vertical one and the horizontal one? That also I will explain soon. Okay, don't worry. So this acceleration, this is like a gravity. You can see the unit here, similar like of gravity. Okay, so difference between vertical and horizontal, or let's explain again deeply for those who don't understand, who are not familiar with earthquake engineering. So horizontal acceleration coefficient, KH, okay, this one is representing the shaking force of an earthquake in the horizontal direction. Okay, so for example, when the ground is pushing, okay, sideways during earthquake, the ground is pushing hard. So this we can take something very simple. For example, if you are in a bus or like any car, in the car, suddenly turn left or right, it doesn't matter. You will see that people inside the car will be like pushed sideways, the opposite direction. If the car, for example, turn suddenly left, you will be pushed like right, in right sideways direction. So, so earthquake is really pushing the ground in horizontal way, and this is the meaning, the shaking force, the power, the force with which the earthquake is pushing the ground. Okay, so if you have a number, okay, the number, this one, the value of this KH is telling you how much of the earth gravity is acting sideways. Okay, you have seen in the previous slide that the unit of this is in the same unit as the earth gravity acceleration. Okay, so for example, if you have KH is 0.2, what is the meaning? It means that the earthquake is shaking the ground with a force equal to 30% gravity, the earth gravity. That is the meaning. I think now you maybe understand the meaning. And in case of the vertical one, vertical acceleration, because you can see during earthquake, some building or some structure are going up and down. Okay, so it's showing the shaking force during earthquake in vertical direction. Okay, so meaning how hard the ground is moving up and down during earthquake. Okay, so similarly, like the example I took for the bus, when you are on the bus and your bus running on something on bump, for example, you will see that you will be like lifted up, up and down. Okay, so similar like that. So if we have, for example, kv 0.1, it means that the vertical shake is 10%, the gravity, the earth gravity equal to 10%. Okay, so I hope you understand now what is the meaning of this kh and kv for those who are not familiar with earthquake engineering. So we need this measured value during earthquake to estimate the bearing capacity in this case, as case condition. Okay, so I will put this here. This is showing us the variation of